Patrick Cook here. So welcome back to the Mandelbulb Epic Rendering tutorial series. This is session 33. Picking up where we left off in the last session, we had worked our way down through these upper options. Now my directory. So Mandelbulb, when I asked it to begin the rendering of the tiles, it created a folder of the same name as I had given the big project name. So here is my folder. So what I'm going to do is I'm going to tell it to browse and find my big render. There we go. There we go. So that's the folder that has all of the tiles. There we go. That's the folder that has my tiles. That's a key setting. Obviously, it's got to know where to find the tiles. Now here we get very interesting. All right, because here, if you recall, I said, excuse me, I said in that earlier window, I said that the file names define the tile positions. So we need to put in the appropriate syntax here, so that this plugin can determine the tile positions. So what I'm going to do is I'm going to come back over here. I'm going to right click and I'm going to do a rename so that I get the whole file highlighted. I'm just going to include that PNG in there. I'm going to do a Control C to copy. And now I'm going to come over here. I'm going to do a Control V to paste. All right. Now, here is where the X is, the X position of that tile is defined. The way the instructions read, all right, for this grid column stitching, all right, is that you put a curly bracket, and then you put an XX and a curly bracket to close it. If you have, let me do this. Let me get my whiteboard back up here. Where'd they put it? There we go. All right, let's clean up a little bit here. All right. So if you have 16 tiles, you're going to have X positions 1 through 4. That's the 1 through 04. Okay, that's the number of tiles across. You're also going to, that's X. You're also going to have your Y. You're going to have 4 positions on the Y. So these numbers right here are indicating the X position, and these numbers indicate the Y position. Now, if I have 16 tiles, all right, I'm going to have these values here are going to be 2 digits. All right, so 2 digits. So an O and a 1, and so on and so forth, off to 99. If I went to 99, if I had 99 tiles, all right, I'm going to have 2 digits up to 99. All right, that's going to be true with the Y as well. So the X and the Y are going to be 2-digit values. That's the point that I'm making. If you had 999, then your X is going to be potentially 3 digits all the way out. 3 digits. Bump, dun, dun. Okay? All right, so in your ImageJ, what you want to do is you want to tell it, look, curly bracket, and then you've got 2 digits, in this case of 16 tiles. So you got to put an X there, and then close that with a curly bracket. That is the syntax to tell this ImageJ that you've got a 2-position X and a 2-position Y. If I had more tiles that got me into a 3 position, then I would tell ImageJ I would give it a 3 position. Closing bracket. Okay? So that's all I wanted to tell you here, that the number of X's that you have in your syntax is going to be the number of positions of your digits of both your X and your Y coordinates. All right. All right, makes sense? All right, so here we go. So we're back to here. So I've got a 2-digit situation. Now I need to go to my Y, start curly bracket. Now this time YY, and end curly bracket. And that's it. I'm ready to go. Now, you don't really need to pay much attention to this, all right, but it's pretty cool. It dumps out the entire merging process into a text file so you could look at it and see detailed what had happened. It's a log, okay? This linear blending is not really something you need to be concerned about because we're only merging side by side. We are not into a stitching. And these options here pertain to this finding control points of these matching pixels for stitching. Don't worry about that. And these values up here are related to the fusion method. The linear blending, that works fine. That's what you want. Keep in mind, there's no overlap. We're trying to butt these tiles up with no overlap whatsoever. So that changes everything. But fortunately, this plugin of this ImageJ can handle this, and so far, for me, has handled it perfectly well. All of these options down here are not relevant. Again, we're not in a stitching and overlap situation. All right. And computation parameters save memory, but may be slower. I don't care. I don't care how long it takes. I really don't. Again, these 16 tiles, when we rendered them out, took 2.5 hours. I don't care. I'm going for quality. I don't care. Take all the time you need. All right, and then the image output, fuse and display or write it directly to the disk. I like to fuse and display it right on the screen, and then if I like what I see, then I can save it, which I'll show you how to do, okay? All right, so what we're going to do is we're ready. We're ready to merge. They call it fuse. I like fuse. But fuse could also kind of imply that there's an overlap that it's figuring out. I just like to use the word merge. So what I'm going to do is I'm going to start this, and then we're going to end the session and let it finish up, and then we'll continue it from there. So I'm going to go ahead and punch this and see whether or not. Now, this display right here is telling me that it's loading all of these images into memory, and it's going to begin to merge all of these. And down here, if we see fuse and display, it indicates that it has found all the tiles, it's figured out what their positions are, and right now it's processing the merging. So that puts us in really good shape. No errors. All I got to do now is just sit back and let it do its magic. It is showing me here the progress. It has 3 steps. It's on step 1 of 3, and it'll go to step 2 and 3 of 3, and we have our picture. Nice. Wow. Wow. I like that. Okay. All right. Let's end this session, and we're going to come right back, and we're going to take a closer look at this and see what we got. Beautiful. I'll see you in the next session.